Good afternoon to one and all. I am Niraj Naidu Vatlamudi, working as an assistant professor in the Department of Computer Science and Engineering, PNR BJIT, Hyderabad. Today in this video, I'm going to explain about emerging technologies in cybersecurity, intrusion detection system. In general, what is meant by intrusion detection system? System called an intrusion detection system which observes network traffic for malicious transactions and send immediate alerts when it is observed. So it is clear that IDS acts as a software that checks a network or system for malicious activities or policy violations. Here, each and every illegal activity or violation is often recorded either centrally using system or notified to an administration. So let us discuss in detail about this concept. So this is a outline, network intrusion detection system, data sets for network intrusion detection, as well as anomaly detection with machine learning. So coming to the first one, that is a network intrusion detection. So here basically we term as a network security, which is critical to every organization as well as computer systems suffer from security vulnerabilities. So what does it mean? Network security is critical to every organization, as all computer systems suffer from security vulnerabilities. Here, network security requires solutions in place for protection from the increasing number of cyber threats. So obviously it is essential for every organization to implement some form of intrusion detection systems that can discover potential threats like threat events early and in a reliable manner. Now coming to the next one, intrusion. An intrusion is a deliberate, unauthorized attempt, successful or not, to break into various parts and access, manipulate, or misuse some valuable property, which may result into or render the property unreliable or unusable. So with the help of these two basic keywords, network security and intrusion, now we are able to define an intrusion detection system. Intrusion detection system is a security tool for detecting unauthorized intrusions into the computer systems as well as the networks. So you know what I mean by unauthorized intrusions. A security system which was used to secure networks from unauthorized intrusions, that is a network intrusion detection system. So what happens? Whenever we introduce this intrusion detection system, this NIDS, simply called as NIDS, network intrusion detection system, so it prevents possible intrusions by continuously monitoring the network traffic to detect any suspicious behavior that violates the security policies and compromises the network CIA, which means confidentiality, integrity, and availability. So let us look into this NIDS. How NIDS is implemented in the form of a device or software that monitors all traffic passing through a strategic point in the network for malicious activities. See, for example, it is typically deployed at a single point. For example, it can be connected to the network switch. So this is a network switch. If any malicious behavior is detected, then NIDS, because this NIDS network intrusion detection system communicates with the network switch, will generate the alerts to the host or network administrator. So like this, the network intrusion detection system will generate some alerts to the admins. So what is the main motto of introducing these network intrusion detection techniques? So simply we can call as what are the goals of NIDS? The main goals of NIDS, which includes detect wide variety of intrusions, detect intrusions in timely fashion, present the analysis in a simple, easy to understand format, and finally is accurate. So let us discuss one by one. Detect a wide variety of intrusions. So this is the main goal of a network intrusion detection system, because previously known and unknown attacks, and suggest if there is a need to learn or adapt a few new attacks or change in the behavior. So likewise, we need to detect a wide variety of intrusions. Second thing, detect intrusions in timely fashion. So with the help of this particular goal, we need to minimize the time spent verifying the attacks. That's because of depending on the system criticality, sometimes it may require to operate in real time, especially when the system responds to some intrusions. Then coming to the third one, present the analysis in a simple, easy to understand format. Like ideally as a binary indicator, that is, normal versus malicious activities. And then usually the activities like whatever the analysis which consists of more complex. And security analysts are also required to examine suspected attacks. Here, the user interface is critical, especially when monitoring a large systems. That means present the analysis in a simple, easy to understand and format. Final goal is accurate, like minimize the false positives as well as the false negatives. Based on these goals of network intrusion detection system, now we are able to define what are the various categories of IDs. See, here in this pictorial representation, I'm able to explain about IDS taxonomy, that is based on the deployment or detection methods. So we know these IDS is basically divided into the deployment method based IDS as well as the detection based IDS. In case of deployment based IDS, we have two categories, host based IDS and network based IDS. Similarly, in detection method based IDS, we have two categories, signature based IDS as well as the anomaly detection based IDS. So coming to the first one, deployment based method based IDS, what is meant by host based IDS? So generally these host based IDS are deployed to monitor the activities of a single host and scan for its security policy violations and suspicious activities. For this, basically, we require some information processing for each and every single node in a network whenever we need to consider networks. Similarly, second one, network-based IDS. This is purely deployed to monitor the activities of all the devices which are connected to the network. So that represents the network-based IDS. Then coming to the next category of intrusion detection system, based on the used detection methods, these intrusion detection systems are broadly classified into the signature-based IDS as well as the anomaly-based IDS, anomaly detection-based IDS. So what is mean by signature-based IDS? Signature-based intrusion detection systems are also known as misuse intrusion detection systems. Misuse intrusion detection systems. Here, the system compares the incoming traffic with a pre-existing database that containing some signatures of known attacks. Here, the signature databases need to be continuously updated with the most recent attacks. So that's why this is called as a signature-based intrusion detection system. Particularly, this method detecting the new attacks for which a signature doesn't exist. That is difficult. So that deals about the signature-based IDS. Then coming to the next category, anomaly detection-based IDS. So anomaly-based systems in which the system uses statistics to form a baseline. That is baseline in the sense, normal usage of the network at different time intervals. So with these anomaly detection based IDS, deviations, there are number of deviations from the baseline usage which are considered as anomalies. So what is the advantage of this particular anomaly detection system when compared to the previous mechanism? The advantage is that these systems can detect unknown attacks. But here also there is one challenge. The main challenge is the high false alarms rate. High false alarm rate. That is, it is difficult to find the exact boundary between normal as well as the abnormal behavior. So these are the basic intrusion detection system categories. Now, network intrusion detection system with machine learning. We know nowadays enormous increase in the network traffic in recent years, and the resulting security threats are posing many challenges for detecting malicious network intrusions. So to address these challenges, machine learning and deep learning based network intrusion detection systems have been implemented for detecting network intrusions. So like just we discussed about the anomalies. Anomaly detection has been the main focus of these ML and DL based NIDS methods due to the potential for detecting new types of attacks. So here, first of all, we need to just look at what are the various data sets that are commonly used for training and evaluating machine learning based NIDS, and followed by a description of the machine learning models used for anomaly detection, and followed by some adversarial attacks on machine learning models for NIDS. So coming to the first one, what are the various data sets for network intrusion detection system? There are several public data sets consisting of records of normal network traffic and network attacks. So what happens here, each and every record in these data sets represent a network connection data packet. Network connection data packet. Now the data packets are collected between defined starting as well as the ending times as data flows to and from a source machine as well as the target machine under a different network communication protocol. Second one, a network connection data packets are saved as a packet capture files. That is a PCAP, packet capture files. So generally these PCAP files have different formats. Like if we take either Linux as well as a Macintosh operating system, they need to call it as a LIB PCAP. Whenever choose the Windows system, then we can call as a WinPCAP. So likewise, based upon the operating systems, these PCAP files have changed their formats. And these PCAP files are used for network analysis, monitoring network traffic, and managing security risks. So the data packets which are allowed to identify network problems, for example, based on the data usage of applications as well as the devices, or identify where a piece of malware that's breached the network by tracking the flow of malicious traffic and other malicious communications. So this deals about the PCAP. Network connection data packets are saved into the packet capture. So we know nowadays the most popular data set for benchmarking machine learning models, particularly for network intrusion detection systems, has been the NSL KDD dataset. NSL KDD dataset. So that is the most popular dataset because they are an updated and cleaned up version of the original KDD Cup 1999 dataset, which contains many redundant files. All of us knows that. Then this NSL KDD contains 150,000 network data packet records. That is, according to the NIDS, we can call as a PCAP files. Here, each and every record has 41 features. Those are shown in this particular table. The features includes the duration of the connection, what is the protocol type, and data bytes sent from source to destination, number of failed logins. So there are around 41 features. So these 41 features are either categorical, binary, discrete, or contiguous. Because many works are selected based on the subset of these 41 features. In addition to that, each and every record has a label, that is whether it's a normal traffic or it's an attack. So this is the deal about the NSL KDD dataset. Now coming to the what are the various attacks in the NSL KDD dataset? Those are categorized into the 4 classes. One is DOS, denial of service. Second one is probing. Third one is U2R, unauthorized access of a normal user as a super user. Fourth one, R2L, that is unauthorized access from a remote machine to gain local access. So we know denial of service, that is by flooding the server with abnormal amount of traffic. And the second category is probing. That's particularly meant for surveillance and other probing attacks to get information from a network. So these are the 4 classes which are categorized under the NSL KDD dataset. So whatever the records which are divided into the training dataset as well as the test subset, these number of records per attack, those are categorized based on the most common attack in the train set, that is the DOS, and the test set which contains attack subclasses that is not seen in the train dataset. So there are n number of examples for these particular attacks. Then coming to the next one, this is CIC IDS 2018 dataset. So this particular dataset was collected with an attacking infrastructure consisting of 50 machines and a victim infrastructure of 420 machines and 30 servers. So with this here, the tested, whatever we can call as the test bed, which includes both Windows as well as the Linux machines. Simply called as it's a collaborative project between the Communications Security Establishment. CS stands for here, Communications Security Establishment, and CIC, that is the Canadian Institute for Cyber Security. Canadian Institute for Cyber Security. It is a more recent data set in comparison to the most popular KDD CUP 1999 dataset. Here the dataset which includes the network traffic records, that is the PCAP files, and system logs of each and every machine captured with the Canadian Institute for Cybersecurity Flow Meter, that is a version 3 device. What does this mean? CIC Flow Meter version 3 device. Here, the records have 80 network traffic features because the previous version which is having only 41 features. This particular version 3, which are having the 80 network traffic features, which includes duration, number of packets, number of bytes, length of packets. So, whatever the features which are missing in the previous version, those are enhanced in this particular version. So, basically, there are some categories of attacks. There are 7 types of attacks according to this particular data set. One is a brute force attack. Second one, heartbleed attack. Third one, botnet attack. Fourth one, DOS attack. Fifth one, DDoS attack. Sixth one, web attacks. Seventh one, infiltration of the network from the inside attack. You know what is meant by brute force attack? Submit many passwords to guess login information. That's happening quite happily. Second one, heartbleed attack. That is a scan for vulnerable applications, like example OpenSecure socket layer, and exploit them to retrieve the memory of the web server. And exploit them to retrieve the memory of the web server, which includes passwords like credit card numbers, private emails, or social media messages. So nowadays, these things will happen. That is, we can call as a heartbleed attack. Third one, botnet attack. This is simply you can call the GEOS and arrays malware used for requesting screenshots from infected devices for every 7 minutes and stealing information by keystroke logging. There is a botnet attack. Fourth one, DOS attack. That is a denial of service attack, which allows a single device to take down the web server of another device by overlaying it with various network traffics. Then fifth one, DDoS attack. That is a distributed denial of service attack, particularly used for devices to take down the web server of a target device. Sixth one, web attacks. So, scan a website for vulnerable applications and conduct some SQL injection mechanism, command injection mechanism, and unrestricted file upload. That meant for web attacks. Last one, infiltration of the network from inside attack. It is a vulnerable application. For example, if you take any PDF reader that's sent via a malicious email attachment, and if it is exploited, it is followed by a IP sweep, full port scan, and service enumerations. So these are the basic 7 types of attacks which are described here. Case of CSC CIC IDS 2018 data set. Now coming to the next one, anomaly detection with machine learning. So we know what is meant by anomaly. An anomaly is a data point, or sometimes you can call it a pattern in data that doesn't conform to a notion of a normal behavior. So here anomalies are also referred to as outliers, abnormalities, or deviations. Anomaly detection is finding such patterns in data that do not adhere to expected normal behavior and given previous observations. So we know anomaly detection has applications in many other domains besides this network intrusion detection, including medical diagnostics, financial fraud protection, manufacturing quality control, as well as the marketing and social media analytics. So here, this is the approach. Let us say this is the first model, that is we can call as a normal behavior. There is a training step. And then exploit it to identify anomalies. This is an anomaly model. So what happened? Anomaly detection can be addressed as supervised learning, unsupervised learning, semi-supervised learning. What is the difference between these supervised, unsupervised, and semi-supervised? Supervised learning means train a classification model using a labeled normal as well as the abnormal samples. Training, train a classification model using labeled normal and abnormal samples. For example, signatures of normal and abnormal samples can be used as features for training a classifier, and at inference level, the classifier can be used to flag abnormal samples. Particularly, this supervised learning approach assumes access to a labeled employees of all types of anomalies that could occur. Second category, that is unsupervised learning. So in case of unsupervised learning, train a model using only unlabeled normal samples to learn the structure of the normal data. At this particular category, at any particular inference, any sample data that is significantly different than the normal behavior, which is flagged as an anomaly. Third category is semi-supervised learning. In this case, train a model using many unlabeled samples and a few labeled samples. Let us say one example, train a model in unsupervised way using many samples, and afterward fine tune the model by using a small number of labeled normal and abnormal samples. So these are the three categories used in anomaly detection: supervised, unsupervised, as well as the semi-supervised. So in these various conventional machine learning approaches have been employed for anomaly detection. First one is clustering approaches, second one nearest neighbor approaches, third one classification approaches, fourth one statistical approaches. So clustering approaches, that is a k-means clustering, self-organizing maps, and then expectation maximization, EM. Second one, nearest neighbor approaches, that is the k nearest neighbors. All of us are familiar in k nearest neighbors. Third one, classification approaches, that is one class single vector machines. Fourth one, statistical approaches. So the state of the art results in anomaly detection have been typically reported by deep learning approaches. So due to the capacity to model complex dependencies in multivariate and high dimensional data, these approaches commonly fall in these categories like autoencoders, variational encoders, and GANs. Fourth one, sequence to sequence models. So autoencoders, an encoder network which maps inputs into a lower dimensional representation. That may be either code or a bottleneck. And a decoder network reconstructs the original input data. So this is autoencoders. So whatever these four mechanisms which are incorporated, like the second one is variational autoencoders. So variational autoencoders learn a mapping from input data to the distribution. That is the encoder network which learns the parameters like mean and variance of a distribution, and the decoder network learns to reconstruct the original data by sampling from the distribution using a latent code. So typically in this approach, a Gaussian distribution is used. If I'm not right, if I'm not wrong, a Gaussian distribution is used to model the reconstruction space. So this variational autoencoder approach is trained by minimizing the KL divergence between the estimated distribution by the model and the distribution of the real data. So that is the variational autoencoders. Third one, GANs. So this is one class of SVM for anomaly detection. Then sequence to sequence models. In case of GAN, the architecture called as a BiGAN, that is a bidirectional GAN, which is commonly used for anomaly detection. So in case of BiGAN, a generator takes as inputs random noise vectors as well as it generates the synthetic samples. This approach is having the additional encoder which is added that learns the reverse mapping. Reverse mapping in the sense how to generate a fixed noise vector from a given sample. So that deals about the GANs. Fourth one, sequence to sequence model. So sequence to sequence models are designed to learn mappings between sequential data like time series signals. So sequence to sequence models typically consisting of an encoder that generates a hidden representation of the input tokens and a decoder that takes in the encoder representation and sequentially generates a set of output tokens. So in this approach, the encoder and decoder are composed of recurrent layers, such as RNN, LSTM, GRU. There are number of layers. Similarly, recurrent networks are particularly suitable for modeling these temporal relationships within the input data tokens. Here, the anomaly detection approach, which is similar to the first model, that is the auto encoders. Auto encoders. So now I need to conclude that anomaly detection with machine learning. So for this, whatever the models, each and every model is having some advantages and as well as the disadvantages. So the table lists the pros and cons of the described these machine learning approaches for anomaly detection. Autoencoder, the advantage is a flexible approach to modeling complex nonlinear patterns in data. Similarly, the drawback is doesn't support variational inference. Similarly, it requires a large data set for training. In second model, variational autoencoders, the advantage is that it supports a variational inference. The drawback, it requires a large amount of training data. Training can take a lot of time. Third approach, GAN, it supports, what is the basic advantage of GAN? Supports a variational inference. That means whatever the drawbacks existing in the previous mechanism, those are overcome these particular new mechanisms. It supports variational inference and it is used for a discriminator signal, allows better learning of data manifold. So likewise, there are n number of models. Each and every model are having some drawbacks as well as the advantages. So this deals about the anomaly detection with the machine learning. So what are the various considerations for anomaly detection? First one, imbalanced data sets. Second one, definition of anomaly. Third one, false alarms. Fourth one, computational complexity. What is imbalanced data sets? So, normal data samples are more readily available than abnormal samples. So, consequently, the model may perform poorly on abnormal samples. And then coming to the next one, consideration, definition of anomaly. Like the boundary between normal as well as the anomalous behaviors can evolve over time because it may require some models to adapt to the changes in the data distribution. Third consideration, false alarms. Many of the found anomalies could correspond to noise in the data. False alarms require human review of the cases, which increases the cost. Fourth consideration, computational complexity. Here, the anomaly detection can require a low latency. Parallelly, this may impose a trade-off between performance as well as the accuracy. Performance as well as the accuracy. So these are the basic considerations for anomaly detection. So with this, I conclude that my concept, that is network intrusion detection system, like emerging technologies in cyber security intrusion detection system. Of course, there are n number of concepts. So this is a very simple concept, that is how machine learning in cyber security network intrusion detection system. So, what we discussed, what is the intrusion detection system? What is network intrusion detection system? What is meant by IDS? What is meant by NIDS? What are the goals of NIDS? What are the various IDS categories? And what are the various data sets for network intrusion detection, like NSL KDD dataset, CSC, CIC, IDS dataset, and anomaly detection with machine learning, that is one class SVM, autoencoders, variational autoencoders, GANs, sequence to sequence models, and finally the comparison between the various anomaly detection models. Thank you, one and all.